In this session, we solve some problem on Gram-Schmidt orthogonalization procedure. From the previous session, it is clear the process of representing finite duration energy signal in terms of orthonormal basis and the signal vector. So now, using Gram-Schmidt orthogonalization procedure, find orthonormal basis function for the signal that is shown below. So, two signals are given, S1 of t and S2 of t. So, let us try to write the mathematical representation for the signals that is shown. S1 of t is ranging from 0 to t. That is why it is written t is greater than equal to 0, less than equal to t. What is the amplitude? A is the amplitude. 0 otherwise, that is beyond this boundary. Similarly, S2 of t is written by mathematical expression having amplitude 2a for this time duration t greater than equal to 0 but less than equal to t by 2, and beyond this boundary it is 0. So now, without deriving the equations of Gram-Schmidt orthogonalization procedure, let us consider the first signal S1 of t, which is represented by the product of orthonormal basis function and the vector value. So here we have to find both S11 and phi1 of t. What is the expression for S11? It is nothing but square root of integral 0 to t S1 square t into dt. What is the amplitude of S1 of t? It is A. What is the time I have to write here in integration? 0 to t here I have to write. After simplifying, I am going to get a root t. So what is the value of the first vector value that we got? S11 is equal to a root t. So based on this S11, we know S1 of t. Just we calculated S11. So how orthonormal basis function is represented? So phi1 of t, that is first orthonormal basis function with respect to first signal, that is given by S1 of t by S11. That means S1 of t is decimated by a factor by S11. So write the S1 of t value here, A, for t greater than 0 less than equal to t, and decimate it or divide it by a root t, that is S11. And finally you are going to get the first orthonormal basis function as shown. So now we have to represent S2 of t, that is second signal, in terms of first orthonormal basis function of first function and second orthonormal basis of second function. Therefore, S2 of t, which is known here, is given by S21 phi1 of t plus S22 phi2 of t. What is S21 and S22? They are vector of real numbers. What is phi1 of t, phi2 of t? They are the orthonormal basis function. Okay. Here phi1 of t is known from this step and S2 of t is known. Already the waveform is given. But S21, S22, phi2 of t is not known. Therefore, we can write expression for S21, that is first vector of real number S21 is given by, you have to integrate S2 of t from 0 to t by multiplying it with orthonormal function, that is first. Here 2 represent second function, 1 represent the previous orthonormal basis function. So what is the operation that is happening? Multiplying. So when you multiply these two signal, you are going to get the integration range. So in order to find the integration range, so let us draw the waveform. Here S2 of t is drawn 0 to t by 2 with 2a amplitude. What is phi 1 of t? Phi 1 of t is represented by this equation. It is having amplitude 1 by root t from 0 to t. So you are now going to overlap these two signal S2 of t and phi 1 of t. You are performing that is multiplication. When you multiply, you are going to get the amplitude of resulting signal, which is 2a by root t from 0 to t by 2, because from t by 2 to t, 0 into anything is 0. Therefore the integration level for this expression is 0 to t by 2. Substitute and obtain S21 as a root t. Now we know what is S21, S2 of t, what is S21 just we calculated, and phi 1 of t also we know from the previous step. But there are two unknowns, that is S22 and phi 2 of t. So let us call this two unknown term as G2 of t, which is not known, which is to be calculated. Since both are not known, therefore we are going to express G2 of t in terms of known quantities, that is S2 of t and S21 phi 1 of t. So now you try to find what is G2 of t. G2 of t is nothing but here S2 of t minus S21 phi 1 of t. So write the waveform S2 of t here, and S21 is multiplied by phi 1 of t. What is the value of S21? It is a root t. What is phi 1 of t? It is first orthonormal basis function existing from 0 to t with an amplitude of 1 by root t. When you multiply that with S21, root t get cancelled and you are going to get a here. So now you perform subtraction operation. Therefore, G2 of t, that is from 0 to t by 2, that is given by S2 of t minus S21 into phi 1 of t. What is the amplitude here? 2a. What is the amplitude of this product from 0 to t by 2? It is a. 2a minus a is a. So now G2 of t from t by 2 to t. So you subtract. What is the amplitude of S2 of t? 0. What is the amplitude of S21 phi 1 of t? It is a. Since minus is there, minus a you will get. So now write the expression for G2 of t. G2 of t is equal to a from t greater than 0 to t by 2 minus a for t greater than t by 2 less than t and 0 otherwise. Since G2 of t is known, S22 is not known, phi 2 of t is also not known. So if I square this, if I square and integrate over TB duration, I am going to get S22 value. What is S22? It is square root of G2 square t into dt. It is square root of G2 square into dt. Perform integration and get this value. Therefore, phi 2 of t is given by G2 of t by S22. Decimate G2 of t by S22 factor and you write this expression. Finally, you have to represent the signal S1 of t and S2 of t in terms of orthonormal basis function. Therefore, final answer is S1 of t is equal to a root t. What is a root t? S11 into phi 1 of t. Phi 1 of t is this. What is S2 of t in terms of the orthonormal basis function? S11 phi 1 of t and S22 phi 2 of t. These are S11 and S21 value, and phi 1 of t and phi 2 of t already we have calculated and written here. So this is the solution for the problem statement that is shown here. We have represented S1 of t and S2 of t in terms of orthonormal basis function.